Here are the notes for 11.2a. To start off, we're going to look at figuring out what's the pattern, and let's find the general rule for these given sequences. We look at the first one, 3, 5, 7, 9, 11. I noticed the pattern. We're just adding 2 to get to that next term. So when we write this, again, we got a sub n is equal to dn plus a sub 0, which is our general rule for arithmetic sequences. And again, if we're adding or subtracting, that is an arithmetic sequence. D, which is that common difference, which in this case was 2, so 2n, plus a0, since this is a1, a0 would be the previous term. So instead of adding 2, we're going to subtract 2 to get to a previous term, which would give us plus 1. Next one, same thing. Subtracting 3 to get to that next term. Okay, so as of right now, we got a sub n is equal to negative 3n. And then if we want to get to that previous term, we're going to just plus 3, which will give us 18, which is our a sub 0, so plus 18. So our rule, a sub n is equal to negative 3n plus 18. On the next one, pattern will be plus 5, plus 5, plus 5, plus 5, and it follows all the way through. Again, let's just go ahead and let's find that a sub 0 right away. Subtracting 5, we get 58 for a sub 0. So our rule in this case is a sub n is equal to 5n plus 58. So today, we're going to strictly deal with arithmetic sequences, identifying them, and then writing general rules, given different information. I could give you the sequence, say write the general rule. I could possibly give you the common difference and a specific term in the sequence and finding the general formula there. Many different ways I can give you information and then finding the general rule. Okay, and again, arithmetic sequence, we're going to be adding the same number every time. Now, it could be subtracting, but again, you can think of subtracting as adding a negative value. So that is our indicator for arithmetic sequence. So just determining if something is an arithmetic sequence, let's go ahead, let's go and try to find that pattern. We look at 5, 11, 17, 23, and if we're trying to determine if it's arithmetic, which is how am I getting to that next term? I would say plus 6. So if that pattern follows all the way through the sequence, then that will tell us that we are arithmetic. 11 plus 6 is 17. 17 plus 6 is 23. 23 plus 6 is 29. So yes, that first sequence is arithmetic. Okay, going this way, okay, I can say subtract minus 2, minus 2, minus 2, and that is true all the way through that sequence. Therefore, yes, that sequence is arithmetic. So I'm going here, negative 10 to negative 6, that'll be plus 4, plus 4, plus 2, plus 2, plus 4, plus 4. And the fact that these right there are saying plus 2 instead of plus 4 tells me that it is not arithmetic. Okay. In order to be arithmetic, it follows that same pattern of adding all the way through the sequence. So in this case, no, it is not arithmetic. Okay, so write a rule for the nth term of the sequence, then find a12. So again, if given a sequence, what we're going to do is find that pattern and then find that a sub 0. So again, a sub n dn plus a0. So finding that pattern, how are we getting to that next term? 32 to 47 is plus 15, and that follows through. So we got a common difference of 15. So 15n, and if I were to work backwards, say minus 15, I'm going to get 17 for my a sub 0. So plus 17. So there's our general rule for the sequence. Now, if you have noticed, the general rules for arithmetic sequences look very similar to slope-intercept form. That is because all arithmetic sequences are linear in nature. If you see, y is equal to 15x plus b. Okay, and if we were to say, think of this as a point, that would be 132, since that is the first term, and that term is 32. So we can say 32 is equal to 15 times 1 plus b, just replacing x and y into 15x plus b. 32 is equal to 15 plus b, or subtract that 15 over and get that 17 is equal to b. So then again, y is equal to 15x plus 17, and again, they look very similar. And again, that is because arithmetic sequences are linear in nature. Now, going back over to then find A12, we're going to use a sub n is equal to 15n plus 17. And again, our n is 12, so a sub 12 is equal to 15 times 12 plus 17, which will give us a total of 197. So A12 is equal to 197. Okay, moving on. Okay, now I'm giving you the common difference in a specific term, and then write the rule for that given. So again, we got a sub n is equal to dn plus a sub 0. And what I have given you is a specific term and the common difference. So what I'm going to do, I'm going to take what I can and plug it in. I have that common difference, so I'm just going to say a sub n is equal to negative 6n plus a sub 0. Now, I have the 20th term in the sequence. Let's say a0 is there, a1. I have a 20. Way down the row. Negative 111. So, again, what we can do, since this is linear in nature, I can think of that point as a point. Okay, n a sub n. Okay, so if I think of this point here as an ordered pair, n, which is 20, and a sub n, what the actual term is negative 111. I can take these values. Okay, here's n, here's a sub n. I can take those, plug them in to help me find my a sub 0. Just like when we're on a line and I need to find that y-intercept. If I have any point on the line, I can find that y-intercept. So we have negative 111 is equal to negative 6 times 20 plus a sub 0. The only thing that is left that is unknown is a sub 0. Negative 111 is equal to negative 120 plus a 0. Adding that 120 over, we end up getting 9 is equal to a sub 0. And then finally, just plugging that back in, we get a sub n is equal to negative 6n plus 9. And since our goal was to find the general rule, given that that specific term and the common difference, we have it right there. So again, if you're given the common difference, plug that in, and then use that other term to help you find that a sub 0. Just plugging that term in to n and a sub n, solving for a sub 0. Okay, now, a little bit different. I'm going to give you two terms, and we're going to find the general rule. Now, what's going to help us is if we think of these as ordered pairs again. Because remember, all arithmetic sequences are linear in nature. So it's always A5, so that's the fifth term, 10, 10. And again, thinking about arithmetic sequences as linear, and we have points, it's like I have a point 510, 3110, and that common difference that we have, the d, that is just your slope. And again, slope is rise over run. So if we think of this as 510, and this as 3110, the rise to get from 10 to 110 would be 100. The run to get from 5 to 30 would be 25. And again, slope is rise over run, which will be 100 over 25, or just 4. And again, our slope is our common difference. So now we know that our common difference is 4. So another option you have compared to just plotting the points and looking at it as rise over run, if you remember, slope is equal to y2 minus y1 over x2 minus x1. Okay, so just taking that larger value of y2, y2, x2, y1, x1. So then just, which was saying 110 minus 10 over 30 minus 5, which again still gives you that 100 over 25, which is the same thing. So we found our common difference, and at this point, it's just like the problem up here. We have our common difference, we have another point, so what we're going to do is we're going to take that common difference, plug it in, okay, and then using one of those points, you can use the A5 term or you can use the A30 term, does not matter. I'm thinking the 510 is going to work a little bit better just because it's a little easier numbers. So again, we got a sub 5 is equal to 4 times 5 plus a sub 0. So a5, which is that 10. So 10 is equal to 20 plus a sub 0. Working back, I'm going to subtract 20, a sub 0 is equal to negative 10. Therefore, just finishing off, writing the general rule, a sub n is equal to 4n. Since our common difference is 4, our initial term is negative 10, so 4n minus 10. There's our rule for the nth term. Now, find the value of n for which a sub n is negative 2. So we're not sure what n is quite yet. So again, if we have a sub n is equal to 4n minus 10, okay, I know a sub n is negative 2. So I'm just going to replace that part right there with negative 2. And what's left is just to find n. I can add 10, we get 8 is equal to 4n, divide by 4, n is equal to 2. So, this is saying a sub 2 is negative 2, meaning the second term is 2. Now, if you want to kind of just check your work, I know in this sequence that I know a5 is 10. And if I know the common difference is 4, meaning I would add 4 to get to that next term. for A6. To work backwards, I'm going to subtract 4. 6. Okay, and if I want to go again, 2, negative 2, negative 6, and that confirms it. Negative 2, that is the second term of the sequence. And then you can also just make sure and double check again. Okay, if I go one more term, negative 10, that's your a sub 0. Yep, it looks like I got the correct a sub 0 term when I wrote my general rule. Okay, that is finding a general rule given two specific terms. That's probably the harder ones of them. Just remember, think of those two terms as points, find the slope, and that gives you the common difference. Once you have the common difference, use one of those points to plug in to find a sub 0. That is 11.2a, Arithmetic Sequences, finding general rules given specific information. You will have an assignment under Chapter 11 homework, 11.2a book assignment. Make sure to work through those. Have a good day.